Okay, we will start from here where we stopped. So in the last section we discussed how we can find out the this matrix representation by using all these equations. Okay, so here is our matrix. So in the first row we have only one, that is corresponding to 1, C1 equal to 0 from that matrix representation. And if you want to check, for example, let's say this fourth equation. Okay, this fourth equation, we want to check this one. Then we have fourth equation. So fourth equation in this matrix we have this one, right? So the first one is 225, this element. Let's take another color. So we have 225, then 15 and 1, and this will be multiplied with A2, B2, C2, right? First three elements are 0, so that will be multiplied with A1, B1, C1, so it will become 0 anyway. But in the second case we have A2, B2, C2, and there are 225 A2 plus 15 B2 plus C2 equal to corresponding fourth y value, that is this one. So that we can see from that equation. So here it is 225 times A2. So the fourth equation is which one? This one. So this one is the fourth equation. If you take 15 square, we can have that values 225. Then the next one is B2 into 15, the 15 B2 and C2, which will be equal to 362.78. that is our y value. So this is the basic idea behind this matrix representation of all these equations. And after constructing these matrices, we have to solve the matrix, this matrix for this coefficient matrix. And once you get all these coefficients, then you can calculate any point in that spline. You can substitute any x value, because you know all the coefficients. Then you can substitute any x value, then you will get the corresponding y value from that spline. So for example, in the present case, we have to find out what is the velocity at t equal to 16 seconds. That was our problem. So we have to check which spline is coming in 16 seconds. So first spline is in between 0 and 10, second spline is in between 10 and 15, and third spline is coming between 15 and 10. So we have to use this spline as our for our equation, for our calculation, because t lies in this range, that is 16 is lies in that range. So we have to consider this the third spline, and this third spline is having this equation with this after substituting this A3, B3 and C3. Okay, so we have solved this matrix, and we find out what is A3, B3, C3 from here, and we have substitute this value in this equation, and we have the entire spline equation with different value of t, and we have to substitute t equal to 16 in that equation. Then we will get 394.24 as our y value, or the velocity at t equal to 16 within that time range. So then after that, what we had to find? We had to find the distance covered in between 11 and 16 seconds, and this can be calculated by subtracting the distance which is covered at 16 minus at the 11 seconds, 16 second to 11 second. So that can be done by using the integration also, integration of vt dt, that is nothing but your distance that is covered. So that you can calculate. So since we have 11 to 16, we have two time region, so we can consider here. So 11 to 15 means we have to consider both this time region. Okay, so 11 will come here, and 16 will come here. So we have to consider both cases. Then we have to use both spline equation. That is why we have to split the integration like this, from 11 to 15 first integration, and second integration from 15 to 16. Okay. Then we will substitute corresponding spline equation for v of t. Okay. Then we integrate and find out what is the final result. That is nothing but your the distance covered by the rocket in between 11 and 16 seconds. And the third problem was the acceleration, and the acceleration at t equal to 16 we had to find out what is the acceleration at t equal to 16, and we know what is the velocity at t equal to 16, that we can represent by using the third spline equation, and we have to substitute 16 for t. So first we have to take the derivative of this spline, that is the derivative of the velocity, which will be nothing but the acceleration, and you will be getting an equation like this. Okay, and that equation we have to substitute 16, so that it will give me the acceleration at 16. So we have substitute t equal to 16, and the acceleration becomes 31.321. So this is the basic idea how to calculate different data points in between each splines. So in this case we have considered the quadratic spline. So if you consider cubic spline, we have x cube plus b1 x square plus c1 x plus d1 as our equation for each spline, and we have to substitute all those values which I have given, which will be given by the data set, and then after that we have to solve this matrix and find out what are the coefficients for each spline, and we have to solve. In cubic case we will be having a little more complicated matrix, and anyway we have to solve all those coefficients, and we have to find out the equation for each spline and solve for different value of x. That will give you all the data points in that particular spline.